Hi, everyone. We are today here talking about adapting Kubernetes to specialized application workloads. This is us. Let's start from the other end. Dawn, please, would you like to introduce yourself?
My name is Chen. I'm a software engineer from Google. I'm also the software engineer and the tech lead since Kubernetes inception. Currently, I'm leading of the Signal community, and glad to be here and talking about the Kubernetes involvement for those specialized of the workloads, like such as the AI machine learning workload and the HPC workloads.
Sachi.
Hi, everyone. My name is Sachi Desai. I'm a product manager on the Azure Kubernetes service team, and my focus area is AI, GPU, HPC deployments onto AKS and Kubernetes as a whole, and I'm involved in the Kubernetes AI toolchain operator CNCF sandbox project.
Vara? It should be on.
Yeah, it's on
Yeah.
now. Hi, everyone. My name is Vara Bonthu. I'm a principal open source specialist SA working with AWS. My key focus areas are scaling data and ML workloads on Kubernetes, especially the Amazon EKS. So my strengths around building some data pipelines using Spark, Flink, and Trino, various other data frameworks on Kubernetes, and also building AI ML platforms on Kubernetes. Looking forward to speak to you all.
Welcome. My name is Erin Boyd. I'm a senior director and distinguished engineer at Nvidia. Super excited to be here. I'm just thrilled to see how many people are here on a Friday. Like 10 years ago, there might have been 7 of us. And, we just went out for beer because, let's just go do that instead. So great to see you all. Hope you've had an exciting KubeCon. I can't wait to hear your questions for the panel.
Yeah, this is exciting. We have the 3 hyperscalers, we have Nvidia. What would you want? So how many of you already have AI workloads in production? Can you raise your hands? Quite a few. And how many are you planning in the next few months? OK, so that's much better. So let me open up a warm-up question to everybody. What is the state of art for your customers? Who wants to go first? What is the state of art for workloads and in general and AI ML in specific? Go ahead.
I can go ahead and start. So I think Nvidia has a really unique set of customers. We service a ton of internal customers that are doing amazing AI ML research, from biological models to robotics. Nvidia is obviously known for its presence in AI, but we're rapidly expanding to an external market, understanding what customers are doing for training and inference, and the workloads are expansive. We have anything from hosting things like DeepSeek to using NIMs and blueprints to go create your own models or augment your models or do fine tuning and training. So I would say we service a lot of customers with an extensive, diverse set of workloads. And, as Don will get to eventually, the hyperscalers are pretty unique in that, not only are we seeing the intersection between Kubernetes and AI, we're really seeing the intersection of HPC and Kubernetes. And how is that rapidly changing our landscape? I think it's an exciting time to be here. And I'd love to hear how many of you, with your workloads and with your customers, are experiencing the same thing.
Yeah, sure. At AWS, you have, pretty much a lot of customers who are running their AML workloads on Kubernetes, which is Amazon EKS, and the focus is in every vertical, mostly in automotive, financials, in every vertical supply chain. They're focusing on it, and one of the biggest example is Amazon Retail, and where Amazon focused on building AI within the retail itself, and which is showing as an example for a lot of these customers at AWS, and they're leveraging a lot of these technologies within Kubernetes, within Amazon EKS, and the open source solutions that came out, building their AI/ML platforms, with all the capabilities of custom scheduling and auto scaling and inferencing and training and fine tuning with various set of tools that we're going to discuss soon. But yeah.
Sachi,
Yeah, on Azure, we see users along different paths or parts of their AI journey. So starting off just wanting to experiment with different models, conduct benchmarking, and evaluate the performance, starting off with serving models and doing inferencing workloads, and then moving forward with tuning or conducting RAG as well to improve the performance and make it more context aware in the context of their applications. And of course, then more advanced AI users that want to train their models, build them in-house from ground up when it comes to more security reasons, governance over their data, et cetera. So we're looking to support them along that journey at whichever stage they're at and meet them where they are with their AI. And I think we'll go into this a bit more in discussing the projects that we're involved in within the CNCF.
Google is a little bit special here. We also have a lot of the mixed workload and also customer at the different stage. So from the training, data processing, preparation, and until to all those kind of the inference serving. And one of the special, like the Google unique, it is Google itself also have the hardware, right? So the Google also have the TPU. So customer came to Google, and not just for GPU, they also have the TPU for cost efficiency, all those kind of the different reasons. And also, we also have like the special things. Google itself build those LM models. And so a lot of customers came to Google, asked for Gemini, and all different of the Gemini, all those kind of things. So one of the special things it is, so internal of those training jobs, or not just third party of those kind of things, and 1P, and some of it is already on the GKE, some is talking about the migrate or on the path to the migrate of the Kubernetes and GKE. So that's kind of give us a unique of the perspective and how to we build of the standardized of the hardware and the uniform of the things and to support the user. And also how to we build a standardized of the framework on top of Kubernetes and to support the different type of the customer things. Yeah.
Thank you. So let me start back from you, Dawn. You are, leading the efforts in Signode in Kubernetes for the things that everybody is going to use, soon, real soon now, like things like DRA, switching on some features like that. So, what the Kubernetes is evolving to suit the AML workloads. There is some work in progress. Last year in Paris and in Salt Lake City, we got everybody excited on all the things that are coming out. So can you give us a status of where they are and what can we expect from the community, and then on the side trying to figure out how and when people can start using it, and also where does everybody think that Kubernetes needs to evolve beyond the current set of things that is in progress?
That's a good question. Thanks. So. Just like of the teams mentioned of the DRA, and also earlier I mentioned that because Google had special, unique space. So then we realized about how to standardize the hardware, especially those specified hardware to support the AI machine learning workload. It is really needed, right? So this is after DRA is trying to standardize and build abstract representative to Kubernetes, right? So the Kubernetes can manage and also schedule all those kind of workload. So there's a lot of progress making those kind of things. And DRA is in the productionized stage, almost in that stage, but we need to figure out a lot of other issues like how to migrate and how to build off the monitoring, all those kind of things. We still is to be, but besides about the hardware, there's the higher end of the objects. And the Kubernetes actually in the past, we start from the support of the web services, right, stateless, and then evolve to support the stateful side. And we don't do really good, we try, but because priority, we didn't do good job on a lot of to support of the batch workload, especially batch workload, the complex batch workload, and with their framework. So we are looking, this is why there's a lot of customer scheduling and the topology aware of the scheduling and also topology management and finding ground of the resource management request come to the Kubernetes community and every day. So community actually build a lot of things like Volcano and also scheduler from Nvidia and also Kueue around of the Kubernetes in the Kubernetes ecosystem, try to do the job queuing, try to do the file sharing and all those kind of things. But because these kind of things we learn a lot more and more, and where the time we realize actually we are missing off the primitives that define the object to support those kind of things, right? So, for example, Kubernetes still today couldn't really support the batch workload, especially complex batch workload, their dependency, right? So the job of workflow and the dependency. How we are going to achieve that? And also, Kubernetes, there's a lot of the core scheduler or customer scheduler define about the pod group, so we can do the GAN scheduling, because especially for training, model training jobs, they really require about all or nothing about the scheduling. And also what it is, how we fast detect of the hardware problem, and then do the hard swap and quick or smart repair about those failure GPU and the TPU. All those kind of things actually is the new challenge for us. So that's we are exciting to work on together with the community.
So, Sachi, when Kubernetes starts making progress, how soon can you get it into KAITO? And what other things can you get it into, either in the community or in the service? What are you thinking about?
Yeah, great question. When I think about where KAITO fits into all of this, more so with the name itself. So as a tool chain operator, as a tool within your entire AI pipeline, we see composable architecture. So plugging it into the other tools that you're using for observability, for checking your GPU node health, for example, and overall making optimizations across the board for different workload deployments. So as Don was focusing on with regards to scheduling and batch workloads, it's great to look at the changes that can be made in the Kube scheduler framework, for example, and there are scheduler plugins that have been proposed as part of certain KEPs, like gang scheduling, co-scheduling, as well as topology-aware scheduling plugins that can support these specific workload deployments, not only just the deployment part, but also long-running availability. So within KAITO, we're looking to just see and validate how these all work together. And another aspect to look at is node health and reliability. So when you have these stateful AI-enabled applications, not only do you want to have successful deployment, but for training, for example, you want to support it throughout the entire workload process. So if there's any kind of interruptions due to changes in the GPU health, you want to be able to migrate that over, let's say, to another node and continue on the process, not lose all of the progress that was made in the first part, and do that in a safe, secure manner so that you can overall reduce costs, because we know that GPUs can often be quite costly and have limited availability at times. So really supporting node reliability throughout the deployment process and considering different aspects of how that can affect your AI-enabled applications.
So, Vara, you are trying to integrate a bunch of these things into things that are useful to customers. You've done things like data on Kubernetes and things like that. So can you speak up about what do you face when you go to a customer, and what their challenges are, and how do you go around figuring out what are the components that you need to put together for them to do the things that they need to do?
Yeah, sure. So probably I might have to tell a little bit of history around before we get into the Kubernetes. And so a lot of the batch workloads or AI workloads traditionally run on HPC or maybe some bunch of CPUs. And in the past, you use clusters like Hadoop for running your Spark workloads. But since the Kubernetes has become more stateless to stateful over a period of time, it's grown, it became more like an AI native platform for all AI/ML workloads on Kubernetes. The main things are when Kubernetes introduced these PVCs with running the stateful workloads, support for the distributed file systems like EFS and FSX and so on, that help move a lot running these batch workloads. So, and these frameworks like Spark, Flink, Prino, and even the AI/ML workloads, Now they start to support to run on Kubernetes by leveraging these features that Kubernetes offers. And there are a lot of operators that have been built over a period of time to simplify this journey. So at AWS and through Data on Kubernetes, we build a lot of patterns to show the customers how you can actually run large-scale Spark workloads on Kubernetes or AML training workloads on Kubernetes, right? So to do that, sometimes you need to think about a lot of things, right? Running these workloads on Kubernetes is pretty straightforward, but you need to start thinking about from the point that you want to bin pack these workloads, distributed workloads, the things that you want to do is GPU optimization and CPU optimization, and bin packing these workloads by running, using custom batch schedulers like Apache Unicorn, Volcano, or Kueue. And you also need to consider the failover. If something goes wrong, can these distributed computing pods can recover from it? So these are the aspects, it's the common aspects that we hear from users and the customers. And they also hit these scalability issues with the Kubernetes. Kubernetes, we say it supports 5,000, 10,000, 15,000 nodes. But with the stateless microservices, yes. Answer is yes. But for stateful workloads like all these data workloads and AML workloads, that changes for workload type to workload, right? There are some set of workloads, like in batch, can go up to 1,000 nodes, just because of the bursty nature of these workloads. But when it comes to AML workloads, you can scale up to maybe 2,000, 3,000. And there's a lot of tuning that needs to be done in every aspect, but it changes based on the framework that you select. So I think it is evolving a lot, and a lot of tools that are coming up, caching techniques and batch schedulers, and optimization on the GPUs using, fraction of GPUs and so on. But there is still a lot to be done in this space by the community.
Thank you. So this is a question to Erin. So as an industry leader, right, you have to lead the industry. You have to take us where you would like us to go. And people are also telling you, this is what we want. So how do you balance the two? And how do you think about where do we put our resources? How do we prioritize requests? What does the future look like? What do we want people to be doing 5 years down the line? How do you think about that?
Great question, Dims. So, I honestly think you'll see a lot more from Nvidia in terms of open source. The landscape.
Thank you.
The landscape is certainly changing. I've been in open source forever and part of the CNCF, and I think we're investing both in our talent and our focus, because we know, as Sachi was indicating, GPUs are precious and they're a resource that needs to be managed. And for us to be able to contribute and have the deep understanding and give that back to the community, how they can easily manage and operate that is, fundamental to all of our success. And, we recognize that we're better together as a community. And so, I don't know exactly, I can't point today, but I'm on LinkedIn. You can always reach out to me. I'm very open, CNCF Slack, Kubernetes Slack. I do want to hear about the use cases. I want to hear about the pain. I want to hear about how NVIDIA as an industry leader can help solve these problems. But there are quite a few actually open source projects in NVIDIA that people probably aren't aware of. There's one called Skyhook that allows you to update, some of the nickel parameters on the fly for jobs that you're running to get better performance. We're going to be publishing a project called NV Sentinel, which looks at the node health. It's not just good or bad, it's in varying different states, and we need to be able to work very closely with our cloud partners to be able to, understand the node health, get them back into service very quickly. And, NVIDIA is not on an island in this. DGX Cloud, which is what I run, the Kubernetes team there, actively works with all the major cloud providers to provide both the technology and the hardware to make that possible. So, I think the tides are changing, and I think, just the relevance of AI within the Kubernetes community is obviously changing. I think at Paris, almost every keynote mentioned something in AI, and it was very different.
It wasn't that bad this week.
It wasn't that bad this week, but I'm thinking back, I had, a picture come up that was Kelsey and I at KubeCon London 9 years ago. And it was 100 people, and I did a keynote about storage. And I remember he was the moderator, and he was like, I just don't think it's ever going to be stateful. Like, you're wrong on this one, Erin. So, things change, and we have to evolve. Right. And this is also just part of our evolution.
Sounds good. So I'll let you go first this time.
Okay.
What is one question you would like to ask the other panelists, or a specific panelist? Pick one. I mean, if I wasn't here, I'm a replacement moderator, just so you all know. There was one more Srinivas who was supposed to be here, so I'm the replacement. So, and they were like, hey, we're just going to ask each other questions, so this is your chance.
I guess I'd pose this to all the panelists, like, what can we do better? To your point, you all are deeply involved. You're all helping customers. Like, what can NVIDIA do to help to be, not even more part of the community, but also just like, this is the pain.
Vara, feature requests.
Yeah, sure. I'm looking at some of the pain points that customers came to me, right? So one of the common pain point that I noticed was, especially for the training, when they're running distributed training across multiple GPUs, and they stream the data from various sources like S3 or other file systems. But sourcing the data, reading the data, and running the training workload takes a longer time because it's missing the caching capabilities. So for the training, it requires proper caching across all the nodes. And a lot of these customers are actually duplicating the data, the entire data set across the nodes to do this training. If there is any possibility around this of sharding the data and splitting across these nodes to optimize, and also building a cache clusters, which simplifies this, whole training part.
Anybody else wants to chime in?
I asked the request to NVIDIA last year at Paris. So I want to repeat 3 asks here, and some already fulfilled by Erin just mentioned something, right? So when it is, I ask for the faster detect of the GPU problem and hardware problem, because often customer did the training, and after they have to do the human involvement validate that the model is correct, incorrect, all those kind of things. There's no visibility, and that's with a lot of time and resources. Thanks, there's a lot of improvement there. And another thing it is, I asked last year, it is the sharing, better sharing GPU. GPU, it is expensive, and it's the how we are going to share, right? So their share have many ways to share, but and also security, like what kind of additional isolation to offer to share off the GPU, and I believe there's some solution we need to work together and to move forward. So last one I ask, it is how to plug in GPU, because GPU is expensive and a special device. So which means a lot of customers have to preserve a physical attach of the GPU to the machines. And once they reserved, and that GPU cannot be used, right? That node also cannot be used. So how we are going to dynamic plug attach of the GPU to the machine, that can totally change about the cloud and how we assemble of the node, right? So that's kind of the 3 things I've been keep asking NVIDIA. Of course, the Kubernetes community and also all of us, like all the partner and the contributor, we work together and evolve. One of the things I really worry about it is because so many of the scheduler idea and so many CRD proposed to customize of the Kubernetes, right? So one of the concerns is we don't evolve Kubernetes, right? So to standardize a lot of things, standardize the DRS, standardize hardware device, and I hope we can also standardize about like a workflow, maybe even not to that high level, but standardize about a group of the pods, describe of the workflow, and so customized of the scheduler can work against those pod group instead of we fragment of Kubernetes for different purpose. Fragmentation sometimes actually is okay because you customize for different industry needed, but that's also is potential for the reduce of the efficiency, right? Reduce about the efficiency and performance, all those kind of things. And also it's not elastic for customer perspective.
Yeah.
So that's kind of the things we need to work together and move forward.
Sachi, before you ask, I'm going to ask people to start lining up if you have a question. And the mic is right there. And if there is nobody, we'll just continue talking. So I hope you have questions and line up. So otherwise, okay, Sachi.
Yes. Yeah, so what we see users trending towards is wanting to learn more about their AI HPC workload, so using different monitoring and observability tools. And there's a lot of interest around, for example, the Nvidia DCGM exporter, and looking for broader support of that tool, maybe across different types of GPUs and compute that's introduced by Nvidia. For example, maybe confidential GPUs and so forth. So just, I would say, like plugging in these tools together and allowing them to be seamlessly deployed, monitoring observability using our kind of standards across Prometheus and Grafana, for example, and then easy integration into all the different cloud providers. And I would say, yeah, generally that's the main feature ask.
Okay, if nobody's coming to the mic, I'm going to, good. Otherwise, I was going to call on people, like Sergey here.
I'm going to answer one of Don's requests just right out of the gate. We just open sourced our Run AI scheduler. It's called Kai, and it does have, fractional GPU. So, I love that you mentioned that there's a lot of schedulers going out there. It's really showing kind of the ubiquitous of what people are focused on. So we're excited to be part of, that of evolution as well.
Thank you. Please. Yes.
Perfect. Yes, I have a question. We were focusing very much on AI and ML workloads, which are certainly very interesting, very hot topic right now. But what I am interested is, what challenges do you see in the context of Kubernetes for the workloads to integrate them beside and beyond GPU workloads?
Excellent question. Who wants to take this?
I can take that. Yeah. Besides GPU workloads, and I think I'll start with the batch workloads if that makes sense, right? So the challenge traditionally on Hadoop clusters where you run a lot of these data processing frameworks, Spark, Flink, and whatnot, Trino. Hadoop clusters used to scale for thousands and thousands of nodes. That traditionally works well. But when you move to Kubernetes, there is a lot of orchestration components which needs to work together to make it work for large-scale workloads, starting with the distributed workloads like Spark requires gang scheduling, right? So, which is something the Kubernetes default scheduler does not support, but then the other schedulers evolved to make that gang scheduling possible. And then optimization of the CPU. So distributed computing heavily relies on the storage, right? So how do we actually use the storage the way we used to use in HDFS, like a common file system, right? So we came up with the PVCs, like leveraging node-level storage and also leveraging some distributed file storage and so on. So those are the areas where improved on Kubernetes, and still there is a lot to be done in terms of the scale aspect. Because we notice when you run like 30,000 pods or 50,000 pods of these workloads, and there is always a bottlenecks around etcd and API servers, it's just because the nature of the bursty workloads and puts a lot of stress on the etcd. So Kubernetes was never designed for that. But now with this type of batch workloads and AI/ML workloads, and there is a lot to be done in this space.
I mean, in the end, your data AI stuff has to be near where your existing stuff is, right? That's why we are trying to do this within Kubernetes. Thanks, Vara. We have one more question.
Hi, my question is more targeted towards Nvidia, but all feel free to chip in. So I was thinking about what could be the future of the scientific community, the research community, along with the open source community, where perhaps we want, as an informal group, all gather together and do something with AI, but we don't have the budget to go to a cloud provider and reserve a cluster with some GPU nodes. So perhaps we all are gamers and have an Nvidia GPU at our home. How can we leverage the ability for the Kubernetes to work at the edge and take advantage of the processing of one of the contributors in that community to allocate some GPU time from their own machine and then all train their open source model?
Yeah, before, I'll just quickly answer one portion, which is if you're part of any of the CNCF projects, CNCF projects have access to cloud credits from everybody, GKE, AKS, and so for example, we run, sanity checks, sanity tests on all 3 providers for GPUs. So, please come join the community. You will have access to some of these things. But yes, for individual researchers and research teams, it might not be the right solution for it. But you're welcome to talk to the CNCF staff. There is various mechanisms where CNCF makes things available. And then I'll hand it over to Erin for the Nvidia side.
Dim's pretty much answered
exactly
what I would say.
I'm sorry.
No, I think it actually brings up an opportunity for us to collaborate more widely. We have a lot of research with Nvidia, across the spectrum. And so I'll look into it. I mean, that's all I can say
I'm
right
sure
now.
you have research programs and scholarship programs and those kinds of
Yep,
things.
we do. But I think it's a great point. And that is why the CNCF went to the cloud providers, got credits, made sure that academics and new startups had the ability, that they weren't constrained by getting compute, right? So.
And also the cloud providers end up not just NVIDIA, but also they do Neuron and Trainium and other things too. So all those things are available to the community as well.
Yeah, great question. Thank you.
Yeah, thank you. Anyone else? Yes, Sergey. Thank you.
Okay. Hello. I will ask you to predict the future.
You beat me to it, dude.
So, how do you see it going forward? Do you think that we will have like Microsoft has like PC in every living room, we'll have accelerator in every cluster, or we will have people calling to some well-known APIs and like only few companies will provide serving and great models. And second, well, I assume that you'll answer first. If you answer first, do you think that, I know all 3 clouds building their own accelerators and Nvidia have an accelerator. Do you feel we will converge sometime and then accelerators will start doing, will be differentiated by capability rather than by vendor name?
Absolutely. And I think this goes actually beyond accelerators. I think this, Vara made an excellent point, is that, the foundations of cloud computing, are the 3-legged stool. They're compute, storage, and networking. And I hadn't had any questions in networking, which I'm kind of shocked because a lot of these benchmarks are based on latency, right? And it's not just within the GPU. So, I mean, I do think the evolution of that is like, how do we do that well? And how do we orchestrate that well? And I think that's why Kubernetes is so important here in tying that infrastructure together. Beyond predicting the future of that, no, I'm not even going to touch that question. But I'll hand the mic off so everyone can take a chance at it.
Yeah. We probably are out of time, but 10 seconds each.
I did hear Microsoft mentioned in there, so I just want to give my 2 cents. But as far as the future goes, I do see users wanting a single pane of glass across all of those main 3 categories. So when it comes to observability, using different tools across GPU vendors or even wherever the accelerators are coming from, being able to have more fine-grained control and monitoring over all of those resources using a single tool, or just creating standards across as well as for networking. So for RDMA over InfiniBand or other approaches to like distributed networks, then how are we going to approach that and make that standard for different types of workloads, not just AI, ML?
Yeah, sure. Just to add to what Sachi said, I think standardization is the main thing. That's now, if you look at AI tools on Kubernetes, there are like a lot of tools, and customers are struggling to understand which one to use it. So things like Anthropic launched this MCP server, right? Standardization, something like that within both training, inference, using GPUs, or maybe using Inferentia and Trainium from accelerators, various other accelerators. There should be a standardized way of accessing these accelerators. And I think that's where that innovation that needs to be done. I think it will be done in future, I guess.
Don has the last word.
Just add what my partner said here. And actually, from my imagine of the world, I even have the proposal since last year, and I want to standardize the different layer, right? So we're already doing that hardware layer, and I want to standardize at the scheduling layer, what kind of the new primitives to efficient of the standardize those kind of things. And also I want to standardize about the auto scaling and the build of the primitives to make those workload, the customer scheduler, right? So for different type of the workload and different type of the batch workload, they give the signal to the Attendees infrastructure, like cloud provider and the GKE, AKS, and the EKS, all those kind of things. They need to scale, auto scale of the node, expanded of the and also VPA, HPA, all those kind of work together. And the most of the important things, what I want in my imagination, it is we can evolve all those batch workload or batch workload framework together, but preserve a lot of those good things, especially of the UX. For example, earlier have the data scientist, one of the data scientists ask, I don't have the answer, how you access the GPU, TPU, all those kind of things, but I want to preserve, you still can using SNRM and SNRM API and the Ray API you're familiar with and submit of your jobs. And once you finish of this, you can use Ray notebook and to do those testing and experimental. But once it is ready to deploy, I hope that deployment it is common and standardized and all those kind of things. So we can decouple on the Kubernetes layer is the core, and I can decouple of the rest of the workload, the detail management based on your lead, and then send it to the Kubernetes. That's kind of my vision, and also I've been pushing since a year ago, and that's just want to share here.
We are out of time. Lovely audience, thanks a lot. Thanks for using Kubernetes. Thanks for trying to use AI/ML stuff on Kubernetes and giving us enough feedback as part of the Kubernetes project. You know, you'll see more stuff coming out. We have 133 coming out, and then hopefully there's stuff that you can switch on and try. And yeah, please give us more feedback and give us your use cases. We'll hang around here for some time if you want to come chat with us. Don, thank you. Sachi, thank you. Vara, thank you. Erin, thank you.
Thank you.